But look at the next one. It says to identify the conic section. If it is a parabola, give the vertex. If it is a circle, give the center and radius. And if it's an ellipse or a hyperbola, give the center and the foci. All right, so for this one, I want to identify the conic section first. It's got two quadratic terms, so that means it's not a parabola. So I look at the coefficients. They're not exactly the same, so it's not a circle. But they do have the same sign. They're both positive, which means this thing is going to be an ellipse. Okay, so now I know that this is an ellipse. And now to find the center of this ellipse, I just have to put it in our standard form for the ellipse. So I've got to complete the square twice. So the first thing I do is subtract the 64 from each side. Because here I'm creating space, I'm going to reorganize everything. So I've got 2x squared plus 20x, little space, plus 7y squared minus 28y with a little bit of space equals the negative 64. Again, I can't complete the square unless I have a 1 in front of my squared term, so I've got to factor out the 2 here with the x's. Factor out the 2, leaves me with an x squared plus 10x with a little space. Here I have to factor out the 7, which leaves me with a y squared minus 4y. And now I can fill in the blank. I complete the square, so I do b divided by 2 and square it. So here that gives me a 25. Here that gives me a 4. And whatever I do to one side, I have to do to the other side. But remember, this isn't just a 25. It's a 25 that's being multiplied by a 2. So that's actually a 50. I've got to add 50 to the other side. This isn't just a 4. It's a 4 that's being multiplied by a 7. So that's actually a 28 that I added to each side. So I have to add a 28 to this side. So now I combine like terms. I factor. Here that's going to be a 2x plus 5 squared plus 7y minus 2 squared equals a 14. And the last thing I have to do, I need to get a 1 over here, so I've got to divide by 14. I use my distributive property to divide each piece. That's going to give me x plus 5 squared over 7 plus y minus 2 squared over 2 equals 1. So that's my standard form, and I did that so I could find the center of this thing. The center of this guy was a negative 5, 2. And that's it. All right. I'm not going to worry about finding the foci for now, and you shouldn't worry about it either. Okay? For the next one, I've got y squared minus 4x plus 4y plus 24. I got to determine what conic section this is. I see there's only one quadratic term here. Since there's only one quadratic term, it means this thing is a parabola. So I know it's a parabola. And now I've got two options for finding the vertex here. I can either put this in standard form and then do the opposite of b over 2a, or I can complete the square once. I'm going to do it each way. The first way I'm going to do is putting it in standard form. So I've got to add the 4x to each side. So I do that. I'm just going to rewrite it. That's going to be a 4x equals y squared plus 4y plus 24. Then I've got to divide each side by 4. So I've got x equals 1/4 y squared plus y plus 6. And now from here, if I want to find the vertex, I've got to do the opposite of b over 2a. So the opposite of b would be a negative 1 over 2 times a, which is 1/4. So that's a negative 1 over 1/2, which is a negative 2. That gives me the y value for my vertex. To find the x value for my vertex, I just have to plug that back in. So I have to do 1/4 times negative 2 squared plus negative 2 plus 6. Which if I plug that in, that's going to give me a positive 5. Okay, so there's my vertex. So I know it's a parabola and I've got the vertex. The other way to do this is to complete the square to put it in vertex form. So I'm going to do that method. For that method, the first thing I need to do is I need to create space. So I'm going to add the 4x to each side. I'm also going to subtract the 24 from each side. Okay, so I'm creating space for my squared terms so that I can complete the square. So that gives me y squared plus 4y with a little bit of space equals 4x minus 24. And now I complete the square. B divided by 2 and squared. That gives me a plus 4. Whatever I do to one side, I have to do to the other side. So now I've got y plus 2 squared equals 4x minus 20. And now I just have to basically solve for x. I add the 20 to each side. So that gives me a y plus 2 squared plus 20 equals 4x. And now I have to divide each side by the 4. Which, again, when I'm dividing each side by 4, I have to divide each of these pieces by 4. There's like a 1 here, so that's going to be a 1/4 y plus 2 squared plus 20 divided by 4, which is 5, equals x. Now, this is in my vertex form. My vertex is -2, positive, or sorry, 5, -2. All right? I take this guy just as it is, gives me the x. Take the opposite of this guy, that gives me the y. And that's it. If I look at the next one, again, it's got 2 quadratic terms this time. Since it's got 2 quadratic terms, I know it's not a parabola. So I look at the coefficients of those quadratic terms. They're exactly the same. They're both +1. So since they're exactly the same, I know that this thing is a circle. Okay, so I've identified the conic section. It's a circle. In order to put this in the standard form for a circle, I just have to complete the square twice. All right, the constant term has already been moved, so I'm just going to rewrite this and create some space, reorganize it a little bit. So it's x squared plus 6x with a little bit of space, plus y squared minus 10y with a little space, equals the -25. So now I can complete the square. B divided by 2 and square it. This is going to give me a +9. This is going to give me a +25. Whatever I do to one side, I have to do the other side, so +9 and +25. This factors into x plus 3 squared, plus this is going to be y minus 5 squared, and this is going to equal a 9. And now this is in my standard form. The center of this guy, I take the opposite of each of these, so that's going to be a -3, +5. The radius, remember this guy over here is r squared, so I take the square root of that. It means that the r value is 3, and that's it. If I take a look at this last example, it's got 3 parts to it. The first part says a brand new BMW costs $68,534 and depreciates at a rate of 21% per year. How much will the car be worth in 10 years? Okay, so this is a depreciation problem, which means I'm going to use the formula y equals a times 1 minus r raised to the t. And I just plug in what I know. The initial amount is $68,534. 1 minus r. The r value is the rate, which is the 21%, which I write as a decimal, 0.21. Raised to the t. T is the number of years, which is 10. And now I just need to plug this into my calculator. Again, be careful when you plug this in. I've got 68,534. I'm going to use parentheses exactly where I did when I wrote the problem down, 1 minus 0.21. Close my parentheses, raise to the 10th power, and I hit enter. And it looks like I get $6,488.99. And I round that to 2 decimal places because we're talking about money, and money should always be rounded to 2 decimal places, so that's how much the car is now worth. And let's say at the beginning of those 10 years, you placed $5,190 into an account with 2.5% interest compounded annually. And we want to know how much will be in the account after 10 years. So now this is the same formula, except instead of a minus sign, it's a plus sign because it's exponential growth. I plug in what I know. The initial amount was the $51.90. The R value is 2.5%, which is 0.025. Raised to the t, which is still the 10 years. And again, I've got to plug this into my calculator. And just be careful. 51.90, parenthesis, 1 plus 0.025. raised to the t, which is 10. And it gives me $6,643.64. Okay. And then the last thing this asked me is after 10 years, would you be able to purchase the BMW from Part A? We'll compare the amounts. It's depreciated to $6,488.99, sorry. And I have $6,643.64 in the account. So yeah, I will be able to purchase this. So the answer to this last question is yes. Okay, I've got more in the account than the car is worth. Hope this was helpful, and good luck on your test.